Today we are going to be talking about section 4b, transformations of quadratic functions. On my table of contents, I have it starting on page 38. So we have a few vocabulary words that we want to review from our quadratic unit. Remember that a quadratic function has a largest exponent of 2. We say that it is a degree of 2 or a second degree. It can have no more than 3 terms. And the form that's going to be new to you guys is y equals a times x minus h quantity squared plus k. If a was 0, then we would say that we had a linear form, and that's not what we're going to be working with. This particular form of an equation is actually called a vertex form. So this form is new, and it is considered the vertex form. Some key features and characteristics that we want to review of our quadratic graphs are that the graph itself is considered a parabola. And it looks like a U, or what some might say is an N. So it's either going to be right side up or upside down, and it is called a parabola. Parent functions, which are all graphs of quadratics, are in the form y equals x squared. That's our parent function. That means nothing has changed. It looks just like that, and it's wrapped around the origin. The point where the graph has a maximum or a minimum point is called a vertex. Now, if it has a maximum point, that means that the graph is upside down, and if it has a minimum point, that means that the graph is right side up, where the vertex is the max or the min. Also similar, we have seen the quadratic equation above, where we have where our vertex form actually gives us the vertex of hk. So in our equation, the h is our x value and the k is our y value. Now remember that this form means that the h is opposite, so we want to remember that from our absolute value graph. And the last thing, which is going to be new to us, is what we call the axis of symmetry. The axis of symmetry is going to act like a y-axis. It's invisible. It is that vertical line that is cutting through our graph. So if I have a parabola that is around the origin, the axis of symmetry is an imaginary line that's cutting through my graph through my vertex. And the equation of this is x equals some number. Okay, so anytime this graph shifts or moves, we want to remember to think about the axis of symmetry. All right, we're going to go ahead and we're going to start to take a look at what happens when we graph a quadratic equation. So we want to take a look at our parent function. Remember that our parent function is y equals x squared. And so what we want to do is create a table of values, an x and a y, and graph them. So I'm going to start with -3, and when I square a negative, it turns into a positive. So we come -3 up 9. Continue on with -2, -1, and 0. And I'm going to actually go all the way down so that I'm repeating my numbers. And remember that a positive squared is also a positive as well. So we're going to see that this graph actually wraps around the origin, and it looks the same on both sides, remembering to put arrows. Okay, so our vertex, that's the point at the bottom of our graph. And in here, our vertex is 0, 0. The equation for the axis of symmetry here is going to be x equals 0. That's that imaginary line that is cutting through our graph, making it symmetrical on both sides. The domain, remember that we're reading our x values, is all real numbers or from negative infinity to positive infinity. Our range, that's our y values, and we're starting at 0, and we are going to positive infinity, or we could say that y is greater than or equal to 0. Now, when we talk about increasing and decreasing, remember we're talking about the slope of our line. So where is our slope increasing? Where is it positive? Well, it's positive on the right side, so that means that x is greater than 0, and it's decreasing, it's negative on the left, so x is less than 0. And remember, this is our parent function, so what we're going to do is we're going to take a look at what happens if we change this. If we have a movement to the right or left, up or down, if we reflect it, if we shrink or stretch it. So I'm going to remind you of some things that go along with those reflections and stretch and movements. But before we do that, let's take a look at what this graph looks like in terms of a shortcut. I don't want to have to create a table of values for every problem, so let's create a pattern. Okay, so here I start at 0. That's my vertex. I go up 0 and over 0. But then my next point is over 1, up 1. My next point, if I go to 2, it's over 2 but up 4. And I'm getting these numbers because I'm taking and I'm looking at the value squared. So I'm going to go over some number and I'm going to go up that number squared. So my pattern is that I'm looking at the square. I'm creating a table, but it's going to be a one-sided table. And so if I go to 3, then I'm looking at 9. And then if I was to go to 4, it would be 16, and so on and so on. What I don't want to have to do is think about what the other side looks like. So I want you to think about a shortcut. This right side looks exactly like the left, and that's because it is being reflected over the y-axis. My domain here is all real numbers, and my range is y is greater than or equal to 0. So remember that you're always restarting at the vertex for the next point, and you're going up and over. Now, before we take a look at a couple of examples, we're going to talk about what is happening in terms of the different types of transformations. So remember that these are the same way as our absolute value that we just finished. The only difference is that we are now using a quadratic equation, and our graphs will always be parabolas, so they should always look like a U. If I have a vertical reflection in scale, that means if there is a negative in front of the x squared, I'm going to reflect it just like I did the last time, which means that I'm reflecting it over the x-axis. If I have a coefficient, say I have 2x squared, that number is greater than 1, which means that I will stretch or multiply my y's by that a value. If I had a fraction like 1/2 x squared, that's a fraction between 0 and 1, I'm going to shrink. But when I shrink, I'm still going to multiply my y values by that coefficient in front. So what we're going to do is we're going to take a look at 4 examples. The first example just has us looking at a 3 in front. Okay, now this form, if I want to put it in my vertex form, I have y equals 3 times x minus 0 squared plus 0. There isn't anything, which means that my vertex is still 0, 0. There's a 3 in front, which means that I'm stretching by 3. So my pattern is to go over some number and up 3 times that number squared. So if I start at my vertex 0, 0, I'm going to go over to 1, but this time I'm going to now multiply 3 times 1 squared, which is still a 3, so 1, 3. Then I'm going to go to 2, so 3 times 2 squared. Well, 2 squared is 4, and 4 times 3 is 12. This is actually going to go off my graph just a little bit. So I'm not going to continue on anymore with the graphing, but if I want to continue on with my points, you can see that each time I'm multiplying by that value squared, and so on and so on. Okay, well, I can't figure out my domain and range until I finished my graph. Now remember that to get the other side, we reflect over the y-axis since there is no vertical or horizontal shift. So that means that I'm going to come over here and I'm going to make a mirror image of my graph on the other side of my axis of symmetry. My domain is still all real numbers. My range is still y is greater than or equal to 0 because I had no vertical or horizontal shifts. Okay. Now let's take a look at what happens when we have a negative in front. What does it do to our graph? Okay, if I plug in a 0, I'm still going to end up with 0. So that means that my vertex is still 0, 0. If I put this in vertex form, it's a negative outside of x minus 0 squared plus 0, which means this is reflecting over the x-axis. So instead of it facing upward, it is now going to face downward. So 0, 0, it's not going to go up, it's going to go down. So I'm going to go down for all of these instead of up. So then if I choose a 1, well, 1 squared is 1, but there's a negative in front, so it goes to negative 1. 2, well, 2 squared is 4, but there's a negative in front, so it goes to negative 4. 3 would make this a negative 9. So we're curved downward. Remember that we reflect this over our axis of symmetry. So the other side is going to look just like this one, but on the other side of our axis of symmetry. The domain doesn't change ever for quadratics, just like absolute value, but the range this time is going down, so y is less than or equal to 0. All right, let's see what happens if we now look at not only reflections, but also stretches and movements right and left. So because I have a value inside and I have a value outside, that means that my vertex is now 1, negative 5. Remember, vertex is h, comma, k. And h is always the opposite of what it looks like. So since this is a minus, it's actually going to be a positive 1. So that means that I am going right 1, down 5, and I'm stretching by 2. So I'm going to start at my vertex 1, negative 5. So 1, 1, 2, 3, 4, 5. And for my next point, I'm going to choose 2. I'm just going to keep going. So to get the 2, remember that we are plugging it into the equation. So we have 2 times 2 minus 1 squared minus 5. Remember to follow the order of operations. So that means I'm going to do what's inside the parentheses. 2 minus 1 is 1. I'm going to square it because that's an exponent, so it's still 1. I'm going to multiply 1 times 2, which is 2, and 2 minus 5 is negative 3. I'm going to do number 3. So I'm going to do 2 times 3 minus 1 squared minus 5. And so that's going to give me 2 times 2 squared minus 5. And 2 squared is 4. And 4 times 2 is 8. And 8 minus 5 is 3. So 3, 3. I'm going to do one more, 4. So I have 4 minus 1, which is 3, and 3 squared is 9, and 9 times 2 is 18, and 18 minus 5 is 13. Well, that's going to be off my graph, so I'm just going to curve it up this way. Now, here's the difference. This does not have a vertex at 0. So what I want to do is I want to draw in my axis of symmetry so I can see how far to go on either side. So for the other side of the 2, I'm going to bring it over here, 1 away. This is 2 away, so I'm going to come over here for 2 away. And that's going to allow me to graph the other side of my quadratic function. The domain is still all real numbers, but my range has now moved down 5, so it's y is greater than or equal to -5. I want you to try example 4 on your own. Go ahead and pause the video. Okay, as you can see, I have completed number 4. There are some decimals here, so if you want to skip those decimals and just go with the whole numbers, then make sure that you pick the values that when you add to 3 are going to give you a whole number after you square and take the half. We're going to have some more practice problems in class, so make sure you come with any questions that you have.